Hello everyone. Welcome to today's video where we'll be diving into the fascinating world of unsupervised learning. I'm the programming professor, and I'm excited to share this knowledge with you. In today's lesson, we'll be covering several key aspects of unsupervised learning. We'll start by understanding the fundamental concepts. Then explore the major categories of unsupervised algorithms. We'll investigate real-world applications of clustering, analyze how outlier detection works in practice, and understand how latent variable models can uncover hidden patterns in our data. This comprehensive overview will give you a solid foundation in unsupervised learning techniques. Let's start with the basics. What exactly is unsupervised learning? At its core, unsupervised learning uses machine learning techniques to identify patterns in data without any prior knowledge about that data. Think of it as letting the computer discover hidden structures in your data on its own. What makes this approach unique is that it works with unlabeled data, discovers hidden patterns and structures, doesn't require predefined output features, and learns entirely from the inherent structure of the data itself. Now, let's break down the main types of unsupervised learning algorithms. We have three primary categories. First, clustering algorithms, which are designed to group similar instances together. Common examples include hierarchical clustering and k-means clustering. Second, we have outlier detection algorithms, which help identify deviations in your data, like DBSCAN and local outlier factor. Finally, we have latent variable models, which relate observable features to unobservable variables, such as expectation maximization and principal component analysis. Let's look at a real-world application. Customer segmentation. In a fascinating case study of mall customer analysis, researchers looked at three key features: age, income, and spending score. They identified 5 distinct clusters, each representing different customer segments. These included young customers with low income but high spending, customers with low income and low spending, those with high income but low spending, customers with moderate income and spending, and finally, those with both high income and high spending. This kind of segmentation is invaluable for targeted marketing strategies. Moving on to another practical application: outlier detection in real estate. In an analysis of 76 single-family homes, researchers looked at list prices and floor sizes to identify unusual listings. They found one main cluster of typical homes and 4 outliers. One particularly interesting example was a 2,876 square foot house listed at $349,500, significantly different from the typical cluster. This kind of outlier might indicate special circumstances, such as a need for major repairs. Let's explore how latent variable models work in practice. Using well-being analysis as an example, researchers looked at various observable variables like exercise habits, cholesterol levels, social connections, volunteer work, hobbies, sports participation, work projects, income, and education. These observable variables were then combined into broader latent categories including physical well-being, social well-being, mental well-being, and personal circumstances. This approach helps simplify complex data while maintaining its meaningful relationships. To wrap up what we've learned today, unsupervised learning is a powerful approach for discovering patterns in unlabeled data. We covered the 3 main types: clustering algorithms, outlier detection, and latent variable models. We saw how these techniques are applied in real-world scenarios like customer segmentation, anomaly detection in real estate, and well-being analysis. These tools give us powerful ways to uncover hidden patterns and relationships in our data. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.